Right, so let's talk about binomial distribution. So in order for us to talk about binomial distribution, we must look at situations which fulfill certain features. Right, so in order for any distribution to be classified as a binomial, first of all, the events must be independent of each other. What this really means is that the occurrence of one event does not depend on the occurrence of another event. So for example, if I toss a coin and it lands up on a head, and if I toss a coin another time and it lands on a tail, those two events were not dependent on each other. Right. Secondly, in a binomial distribution, the number of trials n are either fixed or they're known. Right. So it's not like the number of trials are variable, they will go on and on. In this case, the number of trials are fixed or they're known. Number two, in a binomial distribution, there are only two possible outcomes, P or Q. The only two possible outcomes in a binomial distribution are that either the event is a success or the event is a failure. Right, so when I toss my coin, either I succeed in getting ahead or I fail in getting ahead. Right, and because of this characteristics, P plus Q is equal to 1. Right, because P is the probability of success, Q is the probability of failure, and since these are the only two possibilities, if you add them up, you get 1, because 1 means there's a 100% probability that this will happen, and these are the only two outcomes. Out of these two outcomes, surely whatever you get will be out of these two. Right, so P plus Q equals 1. Lastly, in a binomial distribution, probability remains constant. Right, so throughout my different trials, my probability is fixed, it's constant. So, for example, let's say I go to take my driver's license test, and let's say I have 3 days to pass the test. Right, and let's say on day one, I go there and my probability of passing the test is, let's say, 0.4. Right, and for the time being, let's say I do not pass my exam on the first day, so I go again on the second day. And so, if this situation is a if this situation follows a binomial distribution, then when I go on the second day, my probability of passing the test is still 0.4. Right, so I'm not learning from my past mistakes, the probability is remaining constant. And so when I go on the last day, I still have a probability, a 0.4 probability of getting my test cleared on that day. So in a binomial, it has two parameters. N is the number of trials and P is the probability of success. Right, and what this really means is that any binomial distribution would depend on these two factors, right? So in this case, the 3 days, 3 was my N, P is 0.4 probability of success, and these are the only two factors on which the distribution depends. If I change my number of days or if I change my probability of clearing the test, my distribution will change. It is also to note that in this case, I am not stopping after I clear my test. So let's say if I go after day one and I pass the test, even then I'm still going to take the test again, maybe to see if I perform better or not. Because in a binomial, you're of course not stopping after the first success. Right, so for this situation to be a binomial, I will continue taking on the test for 3 days, even if I pass it or not. Right, so these are the parameters of the binomial distribution, n and p. Right, so just to give you another example, let's say I have two teams, team A and team B. Right, and they're playing a game such that there's no draw in it. Right, so either team A wins or team B wins. In other words, either team A wins or it loses. So let's say the probability of team A winning is, let's say, 0.4 again. Right, and if I'm telling you that this is a binomial distribution, you would automatically say that the probability of A not winning is 0.6, i.e. 1 minus 0.4, because either team A wins or it loses, and so 1 is the probability that anything happens, 0.4 is the probability that A wins, so 1 minus 0.4 will give us the probability that A loses or B wins. Right, so let's say these two teams, they play 3 matches together, 3 matches, and let's make a probability distribution table of this. Right, so here what my x is representing the number of matches that team A wins. Number of matches team A wins. Right, so what are the possibilities? If they're playing three total matches, either team A wins 0 matches, it wins 1 match, wins 2 matches, or wins all of the 3 matches. Right, let's just ignore this. So these are all of the 4 possibilities, and this is the probability of, so this box is probability of them winning 0 matches, this box is the probability of them winning 1 match, and so on and so forth. So, what is the probability that team A does not win any of the match? Right, so let's say first match, team A loses 0.6. There's a 0.6 probability that team A loses. Let's say second match, team A again loses 0.6% chance. Let's say a third match, again loses 0.6% chance. So you just multiply these together, and this will basically give you the probability that it lost in all of the 3 matches. So the probability of x being 0 is 0.6 cube. Right, now what is the probability that team A wins only one out of the 3 matches? Well, let's say team A wins the first match, then it loses, and then it loses again. The probability of team A winning the first match is 0.4, and then losing the second match is 0.6, and then losing it again is 0.6. But we don't stop here, because this is not the only situation where team A will win only one of the matches. This is the first situation. There can be another situation where team A first loses, then it wins, and then it loses again. This would be 0.6 multiplied by 0.4 multiplied by 0.6. And in another situation where team A loses and then again loses and then wins on the third match, this would be 0.6 multiplied by 0.6 multiplied by 0.4. Notice how this is just 3 multiplied by 0.4 squared, 0.6 squared multiplied by 0.4. Right, so let's write it down here, 3, 0.6 squared, 0.4. Okay, so let's take a look at in the combinations where team A wins 2 of the matches. Right, so one combination is that team A wins the first 2 matches and then loses another, which in this case would be 0.4 into 0.4 into 0.6. Then the other probability is A loses and then A wins and then A wins, which is 0.6 into 0.4 into 0.4. And the last combination, the last situation is A wins and then A loses and then A wins again, which would be 0.6 into 0.4 into 0.6 into 0.4. And of course this could be combined to 3 into 0.4 squared into 0.6. So the probability that team A wins 2 of the matches is 3 multiplied by, let's zoom in on there, multiplied by 0.4 squared multiplied by 0.6. Right, and the last situation, what is the probability that the team A wins all of the 3 matches? So day 1 team A comes in and it wins the first match, day 2 team A comes in, wins the second match, and then again wins the third match. Probability that it wins the first match is 0.4, the second match is 0.4, the third match is 0.4, so this would be 0.4 cube. Right, so this is the probability distribution table of this certain situation. Now there's something to notice here. Let me write down the pattern here. So 0, 1, 2, 3, 0.6 cube, 0.3 times 0.4 into 0.6 squared, 3 times 0.4 squared into 0.6, and then 0.4 cube. Here you would probably get a hint why we call this a binomial distribution. If you're familiar with the binomial theorem, which you should be in order to be watching at this video, you will realize that this is actually a binomial distribution, right? So if I write this as 0.6 plus 0.4 to the power 3, this is basically the expanded form of this, right? And any term in this expansion I can get by the formula NCR PR q, n minus r. Or sorry, in this case, we would replace the r by an x, n minus x. So let's first expand this. If you're familiar by the binomial theorem, it will basically be 3c0 multiplied by 0.4 to the 0 multiplied by 0.6 cube plus 3c1 0.41 0.6 squared plus 3c2 0.42 0.6 plus 3c3 0.4 cube. Right, and this is basically equal. Now let's take a look at why this is true. So a recap, NCX basically means the number of combinations in which you can choose X objects from N. So let's say I have some N objects A, B, C, D, E. If I were to say what is 5C2, these are 1, 2, 3, 4, 5 objects. What 5C2 really means, in how many different combinations are there of choosing two objects out of these without considering the order. So A, B can be one of the combinations, B, C can be another of the combinations, A, C, and so on. Right, and A, B and B, A is the same thing. They're counted as one. Right, so when I say NCX, okay, so let's take an example. Let's say out of the three matches you choose two, let's say, and then P2 Q3 minus 2, which is 1. Right, so what is this saying? Why would this give us the probability that team A won two of the matches? Right, so let's focus on this part. This part really just says that P wins two of the matches. Team A wins two of the matches and team A loses one of the matches. Right, so it's saying that the probability of success has occurred two times and the probability of failure has occurred one time. Right, or 3 minus 2 times, because 3 is the total. And what 3C2 is saying that there are these many different combinations that there can happen. So if I scroll up there, this is what's giving us the p squared multiplied by 2, and multiplying it by the number of situations there are in which they occur is the 3C2, which is 3. Right, so this is the reason why it's called a binomial distribution, because when you expand it follows the binomial theorem. And one more thing to notice is that if I add up all of these probabilities, it will give me 1. The reason being that these are all the possible outcomes, these are all the possible probabilities. And just to give you a quick proof, p plus q to the power n is always equal to 1, because we know that p plus q is equal to 1, because in the binomial distribution there are only two possible outcomes, either p or q, and the probability that either of them occur is 1. So 1 to the power n is 1, 1 to the any power is 1, hence proven. Right, so a couple of more things. The expected value or the mean value of any binomial distribution is n multiplied by p. The reason being that p is the probability of success, and so if you multiply it by the number of times, you will get the expected value. Right, so in this case, the mean would be, so n is 3 and the probability of success is 0.4. So in this case, the expected value or the expected number of wins for team A would be 3 multiplied by 0.4, which is 1.2. Right, and the variance, which is a measure of how spread out the data is n multiplied by p multiplied by q. And because variance is npq, the standard deviation, which is the square root of variance, would be square root of npq. Right, so let's say, what if I ask you what is the probability that team A wins two or more matches, right? So for example, maybe team A needs to win two matches in order to go ahead with the second round. What is the probability that it does go ahead with the second round? Right, so what I'm asking is, what is the probability of x, which is the number of matches it played, being greater than or equal to 2. right? So this is the same as saying what is the probability of x equaling to plus what is the probability of x equaling 3, right? Because in order for x to win more than two in order for x to win two or more matches, it either wins two matches or it wins three matches, right? So the probability that it wins two matches will be 3c2. Okay, so p is 0.4 to the power 2, 0.6 plus 3c3, 0.4 to the power 3, 0.6 to the power 1. And whatever this turns out to be, this will be the answer that Team A wins two or more of the matches, or in other words, Team A qualifies for the next round. Right, and one more thing before we end, just remember that NCX as the formula n factorial over r factorial over n minus r factorial. Right, and so NC0 would be 1, NC1 would be n, NCn minus 1 would also be n, NCn would be 0. Right, you should at least remember these situations, because sometimes, sorry, ncn is 1 not 0, because they're sometimes useful when you want to calculate the number of terms, right? So they might ask you how many number of terms are there such that the probability of x equaling 3 is so and so, right? Something like that, right? So that's all for the binomial distribution.